Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Fine. So I'll be just explaining. This was the problems that I gave you in the previous class. And I see here mostly that the first problem, I'll go from step by step. The first problem that you see here is this: they have said in problem number 1 that find the resistance of the circuit shown, and in here the circuit is named as different positions as A, B, C, D. If you can see properly, A, B, C, D, it is written. So these markings are basically done for the convenience of solving the problem, so that resistance of RAB can be solved once, resistance of BC can be solved in another section, and in series resistance of CD can be solved. It is asked that the equivalent resistance A to D, the equivalent resistance is being asked. So we will just go to the solution once. I have Is this visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so the first part, fine. The first part from resistance, they say to find the resistance of RAD. So resistance of RAD means it consists of all the resistances that is attached to the points A and D, including the 5 ohm in parallel and including all other resistance that A and D consists of. From A to D, whatever resistances are there, their equivalent resistance you need to find out. This was the question. So first, step by step, let us move that for the first section, that is AB, from A to B in this diagram, you see there are 3 resistances in parallel: 2 ohm, 5 ohm and 10 ohm. So I have just explained with the statement also that it is said that as 2 ohm, 5 ohm and 10 ohm are in parallel, so we can write as 1 by R dash. R dash is RAB actually. See, I have written in the next step, RAB is actually R dash, which I have taken as the equivalent resistance of section A to B. So from section A to B, we have 1 by 2 plus 1 by 5, 1 by 10, because these are in parallel. Now, one thing is to be noted that in this case, you need to first simplify the term of equivalent resistance for parallel circuits. I think it is already done as 1 by total equivalent resistance equals to 1 by R1 plus 1 by R2 plus 1 by R3. Remember, it is 1 by. So you need to inverse it, 1 by, to only R equivalent, not 1 by. So you need to inverse it so the term can come as like this term. So this is going to be the term in case of equivalent resistance of parallel circuits. So we can write it as 1 by R equals to 1 by R2, R1 plus 1 by R2, and that is equivalent to R1 plus R2 divided by R1 R2. So R solely, or the equivalent resistance for parallel circuit, we can directly put as R1 into R2 divided by R1 plus R2. Getting it, you people? Any are you getting it, everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. Yes, ma'am.
I am telling that you directly put this formula for parallel circuits, that R equivalent or the equivalent circuit equivalent resistance is equals to R1 plus R1 multiplied by R2 divided by R1 plus R2. You put this formula directly, then it will be shortcut and easier for you. Instead of solving 1 by r plus 1 by r1 plus 1 by r2, you directly put r1 r2 divided by r1 plus r2. Okay, so if you do that, then this reduces, like we find RAB as R dash equals to 1.25. People have also showed me as 5 by 4. That will also do. That is the fractional value 5 by 4. That is equals to 1.25 for the section A to B. So like this, for the section B to C, we have two parallel resistances, 6 ohm and 4 ohm. So for the parallel resistances 6 ohm and 4 ohm, I have used this formula and directly I have put RBC equals to 6 into 4 divided by 6 plus 4. Directly I am putting using this formula and we have got this. Okay, so if we get this, then the circuit actually becomes as like this. Okay, everyone understood?
Yes, ma'am.
Yes, ma'am.
So I am just reducing the term and getting it like this. So from the section, earlier from the section A to B, we got 1.25. From section B to C, here we got 2.4, and along with this in series there is 1.35 from in C to D. So we just place it, and along with this entire thing A to D, we have in parallel is 5 ohm resistance. So first we add up these three series resistances, 1.25 plus 2.4 plus 1.35. So these three resistances are added up, and along with this we have 5 ohm in parallel. So if this is obtained, then obviously the total is 5 in parallel to 5. So RAD is basically 5 in parallel to 5, that is 5 multiplied by 5 divided by 5 plus 5. That is 2. Is it understandable by all? Everyone I am asking, not only to those who have shown me, but those who have not solved, for them also. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so this was about the first problem. Okay, this was about the first problem. Now we are going to the second problem. Second problem was this one. This was the second problem. It said that the total power consumed by the network in this diagram, it is 16 watt, and it is asked that the value of R and the total current is asked. So value of R means capital R, and total current I is what we have to find out. And as you can see from the diagram itself, you see 4 and R are in parallel. 2 and 8 is in parallel. So 4 and R, let us form this 4 and R into directly that formula. That means 4 multiplied by R divided by 4 plus R. And similarly, this in the 2 ohm and 8 ohm, we can directly get it as 2 multiplied by 8 in the numerator, and in the denominator 2 plus 8. That is the equivalent resistance for this part and the other part. Now you add up and you get the series resistance. So let us go to the solution. Okay, this is visible now to all.
Yes,
Yes,
ma'am.
ma'am.
So what we are doing, resistances 4 and R, that is in parallel, while 2 and 8 is also in parallel, and these two are in series with each other. So we have reduced this two resistances, means 4 and R in parallel, that is actually 4R divided by 4 plus R. Okay, and this one, 2 and 8, this can be written as 2 multiplied by 8 divided by 2 plus 8, which is equals to 1.6. So 1.6 added with 4R divided by 4 plus R. So this is all about our total resistance in this entire branch. So if this resistance comes, then our total current can be written as this formula, means voltage divided by resistance, because V is equals to IR. According to Ohm's law, V equals to IR. So I can be written as V by R, total equivalent resistance R. So that only I have put. The value of voltage is 8 volt in this circuit. So 8 is V divided by the total resistance that we just found out, equivalent resistance. So we are putting this equivalent resistance in the denominator, and in the numerator it is the voltage. So we find the total current is IT equals to this value. Now this contains this unknown parameter R, means the resistance, unknown resistance that we have to find out, that is there in total current. How we will find out the resistance value of R now? See what was given in the problem. The total power consumed by the network is given is 16 watt. Now power is what? Power is I square R, or you can also write V into I is also power. So these are the different formulas of power that we can use in finding the unknown R. Everyone is getting it now? Please ask if there is any question. Everyone is understanding what I am saying? Any question?
Yes, ma'am.
No, ma'am.
Okay. Okay, fine. So I hope you are getting it. Why I am saying that you calculate the equivalent resistances first, then you have the value of voltage, so you get the value of current. Now, as you get the value of current, you can use the formula of the total power to get R. So we move on to the solution again. Yes, so here we were seeing that the total current we got has this value 8 multiplied by 4 plus R divided by 5.6 R plus 6.4. So moving on to how we use the power. See, total power dissipated in the network is 16 watt. Okay, so 16 watt is basically voltage into current. VI equals to power. So power is given, that is equals to V into I. So V is our 8 volt supply, and IT, the total current that we just found out here. This was the total current. So total current multiplied by this voltage of 8 volt is the power 16 watt that is given. So this will be our equation, and by getting this equation you can solve for the value of R, and solving for the value of R, the answer is 6 ohm. Now many of you have given the correct one, means they have solved in this method only, but some calculation mistakes, due to some mistakes, some people's answer are not this one. So you just check the numerical values, or some calculation errors must be there, but apart from that the entire procedure is correct. Okay, so this is how you will find R. After finding R, you have the total current. You just put the value of this R into IT, or the total current, and you find the total current to be equals to 2 ampere. I hope everyone is writing down these solutions. And if not, I'll provide you the notes also. From there also you can go through. But you must go through, and you should have your notebook or exercise book copy for this basic electrical separately, and all the classes written into that. While you will be the classes when it is going to start, it will be informed to you all. So till then, when you come to class, I want all the classes in your exercise book or copy. Okay, so here we go. Yeah, this is the solution of the second problem. Okay, so this is the second problem. I hope it is understandable by everybody. Now coming to the third problem. Third problem, let us just see what it was. So the third problem was determine the currents in the parallel branches of the network in each resistance and the potential difference between A and B, and it is given that the total power is 488. Again total power is given. See, total power is again given, and you see in this diagram there is three resistances, 5 ohm, 20 ohm and 2.5 ohm in parallel with each other, and along with that in series is a 10 ohm resistance between A and B points. Okay, the three in parallel is between C to D, and from D to B the series one is 10 ohm. So what we have I1, I2, I3, three currents flowing, and the question that is asked is currents in the parallel branches, means you will have to find out the value of I1, I2, I3. The value of I1, I2, I3 is needed, and the potential difference of the voltage between A and B is needed. So you need VAB and I1, I2, I3. Total power is given. So this was the problem. Now you see how it is being solved. See, firstly, what they have done is RCD. RCD means the resistance in the parallel branches, their equivalent resistance RCD is being found out. And it is very simple. It is that formula only, 5 into 20 into 2.5 divided by 5 plus 20 plus 2.5. Okay, so you get this formula, and by getting this RCD equivalent resistance across C to D, you get by using the parallel resistance formula. And when you get RCD, at the same time, the equivalent resistance between A to B is determined by just adding up the series resistance. So you have the total resistance RAB equals to RCD, the resistance previously of RCD between C and D, plus the resistance between D and B, that is 10. So you just add up RCD plus RDB, that is 10. So you get 11.53. This is the first RAB equivalent resistance between RA to B. Now next what you have is the power is given. P equals to 488 watt is given. So that means what? Power or 488 watt is I square RAB. If I square RAB is given, see here you don't know the voltage, so obviously you will have to use the current formula only. If you had V into I, if you had voltage, then you could have written that V into I, that formula. But here in this case, as you do not have the voltage, you'll have to take the current formula only, which is I square RAB. I square R, whatever. So if 488 is the power given, then by multiplying I square into R, that is the value of 488. Now you have I square, you have RAB, means the equivalent resistance across A to B. So if you have equivalent resistance across A to B, and you also have the value of power, then you have I square, because you just put in, instead of I square RAB, you have RAB and you have the power. So I square is equals to power divided by RAB. So power is 488 divided by RAB is 11.5384. Just you find out. So I is the value, by having the square root you can have the value 6.5 something. So 6.5 is our I, or the total current. Now the branch currents that you have, I1, I2, I3, you have got I, you have found the value of I. Now you have to find out I1, I2, I3. But how you will find out? Now we will go to the voltage formula. We will find out the voltage across A to B. Now that is I into RAB. So the voltage, if we get, then we will have the voltage drops across the three parallel resistances. And from the voltage drops, we will get the value of current. From the formula, V equals to IR. Okay. So many people, what I see in general in the previous batch also, formulas they juggle up a bit. Don't confuse with the formulas. Means basic formula some people do mistake. Like I'm telling power is equals to voltage into current. Means P equals to VI. Okay. And V equals to IR. Okay. Now VI and IR, these are separate formulas for power and voltage. Now don't put V equals to VI or I equals to IR, not like that. So remember the formulas correctly and apply it along with by understanding each and every step. So that I will request you go through the formulas, how they are being used in the problem sums. So here you see VAB is the total voltage from the point A to B. And this is what they have asked for the problem. Okay, they our what is the value of I1, I2, I3 and VA to B they asked. So first we will find out VA to B because we already have current I, the total current, and we have the total resistance RAB. So if we have total resistance RAB, we have the value of current I, then voltage V equals to IR is being applied across A to B. So VAB is equals to I multiplied by RAB, which is equals to 6.5033 plus 11.5384. We found out that, and thus 75.038 is coming the value of VAB. So VAB value we already got. Now voltage drop across C to D. You see C to D means the parallel branches, the voltage drops. How we will calculate? We will just subtract VAB minus VDB. So VDB has the resistance 10 ohm. Okay. So across DB the voltage drop is 10 ohm multiplied by I means IR. Okay. So that total current multiplied by 10 ohm gives the part of VDB. So what we do, we just subtract VAB minus VDB and we get 75.038 as our value of voltage drop across CD. As we get this across CD, the drop across all parallel resistance is same because voltage drop across CD will be same voltage across C to D. Whatever the point C to D you are seeing, obviously though those two terminals will be having the voltage drop same in the parallel parts. Okay, because C to D are 2 points only. There are not multiple points. So they are joined by three paths. So the voltage drop across the three paths is the same. So for parallel circuits, voltage drops are same. That is why voltage drop across all parallel resistances is same. Hence I1, the first value I1, I1 is coming as I1's resistance is 5 ohm. So I1 is coming in as 10 divided by 5. 10 divided by 20 is I2 and I3 is 10 divided by 2.5. Okay. So these are the solution for the third one. Everyone clear? Any question?
No, ma'am. No, ma'am.
And please write down everything what the problems are there.
Ma'am, I square value is 6.5.
No, I is 6.5.
No, we have to find square root of 6.5, na ma'am? I square value.
First, you find out what is 488 divided by 11.5. What is it coming? You see, I have directly written the square root value. 488 divided by 11.53, whatever it is coming, root of that will be done, and that is equals to 6.5.
Ma'am, 42.324 it will come, ma'am.
Yes, now root over of that is 6.5.
Correct, ma'am, correct.
Is it clear?
Yes, ma'am.
Clear, ma'am.
Okay.
Yes.
Any other confusion? Anyone having any other confusion? Okay, so I'm moving on to the fourth problem. If any confusion is still left, do watch, take your time, see the solution, then you ask me if anything is not clear. Okay, so I'm moving to the fourth and the last problem that I gave. This is the fourth and the last problem. See, here many things you have to find out. There are four portions actually. 1, 2, 3, 4. Many things you have to find out here. This is again a circuit where there are two parallel resistances. Along with that, in series is one series resistance. Okay. So what here is asked is, they have told that out of the two parallel branches, current was flowing. So out of the two parallel branches, I2 and I1. You see there are two parallel branches, I1 and I2. Means two resistors are there, 2 ohm and 30 ohm. Out of 2 ohm and 30 ohm, I1 is flowing and I2 is flowing. I1's value is given, which is 1.2 ampere. So if you have one value of I1, I2 is not given. What you already have, can you see from this, just from this diagram, I'm just asking you that you have 1.2 ampere as I1 flowing through 30 ohm resistance. That means already we have got what?
Resistance.
Voltage.
Right, voltage. Because you see voltage is V equals to IR. That means I1 is given, R is 30 given. So 1.2 into 30 is our voltage across the parallel circuit. So if we have voltage across these 2 points, same voltage is across the 20 ohm resistor. So if we have same voltage, current I2 can also be found out by the same putting the value of voltage V equals to IR.
Yes,
Is it
ma'am.
right?
Yes, ma'am.
So let's find out the solution. What are the things asked here? I'm just telling in short. They have said find the currents in 20 ohm and 15 ohm. 20 ohm resistor and 15 ohm resistor, what the current is flowing through it. Okay, that they have asked, number one question. Number two question is voltage across the whole circuit, entire circuit, the voltage means V. What is the battery voltage V? That they have asked. And Third is the voltage across 15 ohm and 20 ohm. Again, the voltage across 15 ohm and 20 ohm also they have asked. Okay. And the last question is the total power consumed in the circuit is also asked. Earlier, the total powers were already given, right? Using the total power, we were finding it out. Here, instead of total power, they have told us the value of I1 equals to 1.2 ampere. So this will be already used for finding all this. Let us go to the solution. Yes. So this is the solution. First let us discuss see the value, the circuit. According to the circuit, I1 is given. So the voltage drop across parallel resistors is the same that I was saying. That the voltage across the 20 ohm resistor and 30 ohm resistor is the same. And voltage across the 30 ohm resistor is easily find out because I1 is given. So 1.2 multiplied by 30 is the voltage drop, and the same voltage drop is in case of whatever is in the 20 ohm resistance. So you just put the value and find the I2 that is flowing through 20 ohm. I2 is flowing through 20 ohm, has the same voltage. So 1.2 into 30 equals to 20 into I2. Once you find out I2, 1.8 ampere it is coming. Fine. Now you can find out I15 means 15 ohm resistor. Here you see the 15 ohm resistor. So 15 ohm resistor, what is the current flowing through the 15 ohm resistor? That is easily find out by I1 plus I2, because I1 and I2 plus I2 is only I. They are adding up. I is the same current that is flowing through the series resistance, because in series the current remains the same and in parallel the current divides. So the divided current I1 and I2 you just add up and you will find whatever I is that is flowing through 15 ohm. So that is our I15 that we have already found out. Next is number 2, that is V equals to voltage drop. Voltage drop across 30 ohm plus voltage drop across 15 ohm. Okay, voltage drop across 30 ohm and 15 ohm. How to find out? Because 1.2 into 30, as I told you, 1.2 into 30 is the voltage drop in the 30 ohm. So add up that with 3 into 15, because 3 is the value of current flowing through this 15 ohm resistance. Okay, we just found out that 3 ampere it is coming. So 3 multiplied by 15. Now you get the total voltage which is coming as 81 volts. See, 81 volt it is coming. V will be equals to 81 volt. Okay, now they have said find the resistance across 15 ohm and 20 ohm. So 15 ohm we already found out. 15 ohm the resistance will be 3 into 15, which is 45, and across 20 ohm, this upper part is obviously it is also find out it is 36 volt. And the power consumed, finally the power consumed is separately being calculated into I square R plus I square R plus I square R. So you add up all the I square R's and you get the total values. Everyone clear with this problem?
Yes, ma'am.
Yes, ma'am.
Yeah, I will request, I will just say all of you to just sit with this problem, concentrate with this problem, and you will get to understand. If you have not understood, just keep in mind the basic features of series and parallel circuits. If you know the basic features of series and parallel circuit, then it is very easy, and not to worry, you will understand. Just sit and go through them. It is very important to go through the problems so that you can ultimately do. Don't mug up the problems. Don't try just mugging it up, just like learning the problems. Problems are not for learning, they are for solving. Okay, so don't just mug up these things. Go through the problem so that any new circuit if I give you, then you are being able to solve. Okay, so this was all about today's class. I just wanted to solve the problems for you all. And many people have tried very well. So very good with that. The effort was very good. Everyone understood the problems?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, fine. Fine, good. So I'll be just stopping this presentation now, and I'll take your attendance. Okay. Roll number 401,
Yes, ma'am.
402,
Present, ma'am.
403.
Ma'am.
Okay. 404,
Present, ma'am.
405.
Present, ma'am.
Someone is unmuted. Please mute. Okay. 405 is present.
Yes, ma'am.
406, 406, 407,
Present, ma'am.
408,
Yes, ma'am.
409, 410, 410, 411,
Yes, ma'am.
412,
Present, ma'am.
413, 413, 414,
Present, ma'am.
415,
Present, ma'am.
416,
Present, ma'am.
417,
Present, ma'am.
418,
Present, ma'am.
419,
Present, ma'am.
420, 420, 420. Roll number 420. I think it is Kaustab. Kaustab, are you there?
Yes, ma'am.
Okay. You are 420, na? Roll number?
Yes, ma'am. Yes, ma'am.
421,
Present, ma'am.
422, 422,
Present, ma'am.
423,
Present, ma'am.
424, 424. Roll number 424. Roll number 425, 425, 426,
Present, ma'am.
Ma'am, 425 is present.
okay. So 425, 426, both are present. 427,
Present, ma'am.
428, 428, 429,
Present, ma'am.
430, 430, 431,
Yes, ma'am.
432,
Yes, ma'am.
433,
Present, ma'am.
434,
Present, ma'am.
435,
Present, ma'am.
36, 436, 437,
Present, ma'am.
438,
Present, ma'am.
439,
Present, ma'am.
440,
Present, ma'am.
441, 441, 442, 443.
Present, ma'am.
Okay. 444, 445, 446.
Present, ma'am.
You are 446, right?
Yes, miss.
Okay. 447,
Present, ma'am.
448, 449,
Present, ma'am.
450, 450, 451,
Present, ma'am.
452, 453,
Present, ma'am.
454,
Present, ma'am.
455,
Present, ma'am.
456,
Present, ma'am.
457, 458,
Present, ma'am.
459,
Present, ma'am.
460.
Present, ma'am.
Okay. So I'm over with the attendance. You can join the next class now. Everyone, thank you for everyone for this class. And leaving, you can also leave.
Ma'am, 406 present.
Where were you when I was calling?
Ma'am, I went to washroom.
I'm leaving this class. You can leave now, everyone. Thank you.
Okay, ma'am.